Alright everybody, here's a quick lesson on our key terminology for our statics class. So we do have three branches. We have rigid body mechanics, deformable body mechanics, and fluid mechanics. Both the deformable and fluid are future courses that you'll be taking within the CET and MET classes. What we're going to be diving into is the rigid body, which is divided into your statics and your dynamics classes. So basic quantities that we have are length, and that's a scalar, so is time, so is mass. And what we have is length is used in determining distances and geometric properties. Our units are mainly in meters and feet, but sometimes you may see millimeters, you may see centimeters, you may see inches, and sometimes you'll see miles. Time, conceived as a succession of events. What you can think of as statics and time, not time, are independent of each other. Mass is a measure of quantity of matter that helps compare the action of one body to another. And then in forces, you got something like a push-pull. So if I'm pushing against my neighbor and he's pushing against me and we're not moving, well then we have forces against each other. So the force could actually push and move something, or the force could just be pushing and being equally pushed against me. We'll be getting into Newton's laws here in a little bit. So we can look at a particle. When we're looking at a particle, you're looking at that it has mass, but you can sometimes think of the size being neglected. Like the example there says, Earth within its orbit. When an object is idealized, then the actual geometry is ignored. A rigid body, that's a number of particles that stay the same distance from each other, and it does not deform under load. Concentrated load is a load that is assumed to act on a point of body, which could be like a wheel on the ground. So your units of measure, we got SI units in mass, kilograms, time is seconds, distance we're going to be talking about meters. The unit of force is a Newton, and the definition of a Newton is the force to accelerate an object of 1 kilogram at 1 meter per second squared. So if I have a mass of something of 1 kilogram and I use an acceleration to push at 1 meter per second squared, that is a Newton. And then you can see there that the units of a Newton is a kilogram meter per second squared. And when you're talking about acceleration due to gravity, using the SI units, you're using 9.81 meters per second squared. US customary units, with the unit of mass is a slug, distance is in feet, and again time is in seconds again. Slugs is the amount of matter accelerated at 1 foot per second. And then your units is a slug is a pound per second squared, pound second squared per foot. And you see the gravitational acceleration there is 32.2 feet per second. Alright, so just going on forward, just making sure that you're using your engineering format. Use the GFASA, that stands for given, find, approach, solution, answer. And I do have some examples there on Canvas for you to look at. This helps you complete all work neatly, and it helps you keep yourself organized. Another important thing is your dimensional homogeneity. You can't use feet and newtons. You can't use pounds and meters. Make sure you're working within the same unit, the same system, and make sure that if they are given 2 units, make sure you're trying to figure out what you're solving, what system you want to solve into, so you can do your conversions correctly. At the end of each problem, you want to look at your answer. You want to analyze it to make sure that the answer makes sense. If I'm solving for a triangle and I'm solving for the big angle, it's got to be the opposite of the largest side of the triangle. So just make sure that your answer makes sense. So that's it for this video. I'm going to be uploading one a little bit here for Newton's laws. Hello everybody, back again. We're going to talk about Newton's 3 laws. And if you were in class right now, I'd be asking, alright, does anybody know what Newton's first law is? And if you know it and you just recited it, awesome. If you don't, pause the video, take a second, think about it, and then come back. Alright, so Newton's first law. It's an object at rest or constant motion with no unbalanced forces. So if I have a sphere and I have forces acting on it, we'll say this is force 1, force 2, and force 3. And that means that possibly this is at rest, having these forces being acting on this object. Or maybe it's moving at a constant speed, at a constant velocity. Alright? Newton's second law again, pause it if you want to think about it for a second. If not, what is Newton's second law? Well, it's a particle that is acted upon an unbalanced force. And normally when we talk about Newton's second law, we're talking about force is equal to the mass times acceleration. So if I have an object and I have a force going along there, I have some type of acceleration of this object moving to the right in this case. And then we have Newton's third law. And when we talk about Newton's third law, what are we talking about? Well, we're talking about mutual forces acting upon an object in the opposite and equal direction. They're collinear, we'll say. So we could say, alright, so I've got this object, and I've got a force, call it force 1, acting on the ball. And then I've got a force 2, acting on this ball or object. And they are acting upon each other. So it's the action is the same reaction. So they're just pushing on each other. It's an action-reaction law. Something else I'd like to discuss real quick is the Newton's law of gravitational acceleration. So we have an equation, and its force is equal to G over m1 times m2 over r2. So what is F? Well, F is the force of gravitational between two particles. Force of gravitational between two particles. Think of the Earth and the Sun, right? G is a uniform constant of gravitational acceleration. And that is 66.73 times 10 to the negative 12 meters cubed per kilogram per second squared. And then what you have is M1, M1 and M2. Those are your particles. And these are the mass of the particles. And then R is the distance between the two particles. So if you're thinking about this, you can use this equation, assuming Earth to be a non-rotating sphere of constant density, mass 2 is equal to mass 1 is equal to the mass. We can get this going, and we come up with this equation. And I'm not going to derive it right now, but we can say that W is equal to mg. So W is equal to the weight. M is equal to the mass. And G is equal to your gravitational acceleration constant. So that's 9.81 meters per second squared, and so forth. That's just a quick overview. What I'm going to do now is I'm going to go ahead and create a couple of videos with just some unit conversions and just an example on this, just to help us move forward. Hello everybody, welcome. I will be talking a little bit about some unit conversions, and we'll do a problem using the gravitational attraction of Earth on a person. So we're going to be doing 3 examples. The first one is already here on our screen. We have a given of 15 kilometers. That's our distance. And the time that we'll be traveling is 38 minutes and 1.3 seconds. And what I would like us to find is the average speed from kilometer per hour, and then from miles. That's going to be miles, not meters, miles per hour as well. So when you look at this, you're looking at your approach. We want to think of our homogeneity and our units. And so when we're going in to solve this, if we're going to do point A, we're going to say, okay, our speed is equal. Now we're saying that this is going to be equal to 15 kilometers over. Now when we convert our time, come over here to convert our time, we have 1.3 seconds. Now we got to go to hours now, so we're going to say, okay, well, 1 minute is the same as 60 seconds. And we know that 1 hour is equal to 60 minutes. So by looking at this, we know that our seconds are going to cancel, and so are our minutes. So we're going to land up with hours. So by doing this and punching this into our calculator, I'll give you a second to do that. You can always pause the video at that point. You come back, plug this in, and you're going to get a total of 0.63369 hours. So now we can plug this time in for our speed, which will be 0.63369 hours, which, plug that into your calculator, you're going to get 23.7 kilometers per hour. So for part B, since we already have our time, it'll be real easy. We can say that 23.7 kilometers per hour, and we know, if we look this up, that 0.621 miles is equal to 1 kilometer. So you see here, our kilometers will cancel, we'll end up with miles per hour. You plug that in your calculator, you should get 14.7 miles per hour. Good. Okay, so let's go on to our second problem. So now we're in our second problem. Now we're given a cross-sectional area of a C12 by 30, so that's a C channel, and we're talking about the area, the cross-sectional area. So we're talking about that area that's highlighted there in red. So when we come over there, we're asking to find the cross-sectional area in millimeters squared. So our approach is just going to be a unit conversion, and our solution is pretty easy. We know that 1 inch is equal to 25.4 millimeters. So knowing this, we can use our conversion. So we can say 8.81 inches squared, and then I can come in and say, okay, 1 inch is going to go on our bottom, and then I got 25.4 millimeters on the top. That way I know that my inches were going to cancel at some point. But if you look at this, inches squared and inches aren't going to cancel. So what do I need to do here in order for my inches to cancel? And what am I actually looking for? I'm actually looking for an area. So I'm going to need this in millimeters squared. So I can just square both the numerator and the denominator to get my solution. So this, then my inches would cancel out. So then plugging this into my calculator, I would get my area is equal to 5,683.9 millimeters squared. And proper way to do this would say, hey, this is my answer, and I boxed that in. I should have done that with my previous as well. Box those in. You could also use a highlighter and highlight those in, so it's really easy for me to find